Guys, no, this isn't great. This is only week number 3 and you're not doing your homework. I only gave you 3 questions to do. But I only gave you 3 small questions to do for the weekend. You know, this isn't going to be great.
This is the reason you took it lightly.
It's small, you know.
Okay, so you're saying I need to give you more. That's your words. That's your words, not mine.
Thank you very much.
Do you get my point? Like, you know,
No, I understand. You need more questions, not less.
Thank you.
I understand.
Yeah, actually, like, if I had more question, I would not have done it.
Yeah.
You know, like, it's
Yeah,
only
yeah,
one
yeah,
question,
yeah,
you know,
yeah,
like,
Right, what was the speed of the ball?
50.
Well, if you didn't do, well, you did it anyways, did you?
Yes.
Yes, okay. So 50. And what was the angle?
30, 45, and 60.
30. Okay, well, if you didn't do it, I want you to try it now. I asked for the range, isn't it?
Yes.
So before you can get the range, you need to get the time of flight. That's the T. How long until it hits the ground here? Okay. Now, so I'll just give you a minute to do that. Now, what was the biggest of your 3 answers?
supposed to be 45.
Well, did that match up with what you got?
Yeah.
Okay. We'll have to wait for your classmates. They weren't as good as you in doing their homework.
Oh.
Well, I know you tried anyways, but I think I would like you to do it again with a different calculator, okay?
Without calculator?
No, with a different calculator. Here,
Okay.
you can borrow mine for a minute.
Okay.
Can you pass that down to next? Now see if you get the right answer this time. So how are we doing with that one? Did you get an answer for the time? Now, what I'm doing here is I want to do it so that I can change the numbers. So I have the angle, the speed. Did you get that for the ux and the uy? The horizontal and the vertical components. Yeah? Is that right? Did you get that? What do you mean no? Did you type in 50 cos 30?
The time?
No, not the time. The ux and the uy.
I did for the 50 cos 30.
And what did you get?
I got 43.3.
Okay.
And for the cos 45, I got 25 root 2.
Okay, yeah, we'll just look at the 30 first. Did you get the time?
You just have to find time.
No, we have to find the range.
Well, the time before the range, yeah. So look, if you want to find the time, you need u, v, a, t, s. Now let me just delete that and call it theta instead of 30. So the u will be 50 cos theta, the v will be 50 sine theta, the a is minus 9.81, and the s is 0. So you have s equals u t, and then a half a t squared. So you get 0 equals 50 cos theta minus 4.905 t. So this equals 0 or this equals 0. That doesn't work. So we'll say t equals 50 cos theta over 4.905. So that's the time depending on what angle you're using.
This is V equals?
This one is S equals.
So it will be like 5.09 for the
5.09 is it? Yeah. Let's have a look at it. So the time,
formula and then we'll put the values.
No, it's not the same way we did it in the class last week.
which one?
The way you did it is a bit different than the way we did it.
Way I just did it or the way he did
The
it?
way you did it.
Way I did it?
Yeah, the way.
What's different?
No, I mean, of course it's the same answer in the end, but
Same.
we divided the x and the y, so the v was unknown for the x.
Ah, yeah, I just didn't write down the X part. This is the Y part.
Oh, okay.
That's all. Yeah. 50 sine divided by 4.905. What was that the time you got, was it?
Yes.
Yeah. Great. Okay. So now I have to calculate the range. So now EAD, I can look at the X part. I was just doing it one at a time.
Yeah.
So the U is, oh my goodness. Sorry, now I realize. Now I sorry. That's stupid. Sorry. What the?
We should be.
Yeah, no, I know it's stupid. Sorry, I see it now. I wasn't thinking. Sorry. That was stupid. Yeah. The U is. Where's my pen gone?
25.
Yeah, but I want to just write it in. The U was U sine theta, because we're looking at the vertical. Yeah. Sorry about that. What the? Oh man. I screwed this up big time. Right, I'll just start again. Sorry, folks. Right, now that we're awake. Right, this is 50. This is what I meant when I was writing that down. This is 50 cos theta, and this one here is 50 sine theta. And then let's do this carefully. Now we have our x and we have our y. So here u is
25.
50 sine theta. V, don't know. A minus 9.81. T, we don't know. And S, 0. Okay. Now we'll use our S equals U T plus a half A T squared. So that means 0 is 50 sine theta minus 4.905 T. T t, so it's the same, I just missed up the sign. The t should be 50 sine theta over 4.905 instead. Now for the x, what's the u? 50 cos theta, yeah, which whatever it is. The v we don't know, the a is 0. The t we do know, it's the answer here. And the s, we don't know, and it's actually what we want. It's the range. And because there's no acceleration, we can use our distance, speed, time triangle. So distance is speed multiplied by time. So the answer will be 50 cos theta multiplied by the time I got here. So let me just change that in my spreadsheet. That should be, I had it right in here. It was, somehow I made two mistakes and both fixed themselves. Yeah, so that's right. And then the range is, yeah, the range is the time multiplied by ux. Well, I see, because I'm rounding off up here. You know. Is that okay? Yeah. So what happens if I change the angle? Let me.
It will come less.
Well, let's see. Let's hide these. Okay. So 31. Actually, you know what? Let me make it no decimal places. Make it a bit nicer to look at. 31 degrees. 32 degrees. What's happening? It's increasing. That's 45. Whoops. Now, what should happen? Yeah, it should start to decrease now. What will this one be?
It will be the...
Yeah, so what's the range?
So it will be 250.
Is it 0?
Yep. Because if it just goes straight up,
Down.
it doesn't travel across anything. And what about this one? Kind of weird. It's 0 because it doesn't get launched. Yeah?
It has no projectile.
It's not a projectile then. So if I put out 1 degree, I get 9 meters. If I put out 2 degrees, I get 18 meters. 3, I get 27. So you see it very quickly increases. Yeah? Okay. What about if I put in like 91 degrees?
0.
Mm-mm.
It will be close to 1.
91 degrees. What happened?
To become less.
Yeah, so what number should I expect here?
A normal number like 1, I think. Because
In decimal?
Minus 9.
why?
Because if it's 91 degrees, it's being launched backwards.
Oh.
So that's why the range comes in as negative. Yeah? Okay, anyways, I kind of wanted to do this question so that you can see the range change, and you can see that this one makes it a maximum, or well, rather I should say, that is a maximum there, and this is the best angle for maximum range. Yeah. Okay, we'll continue anyways. I think it's good to have a picture in your mind what's going on. Also, actually, you know what? Just before I leave it, since I went to the trouble of making it, show rows. So you can see here that 4.905 is G. Well, it's a half a G in my formula. So if I divide this by 7, that's like the gravity on the moon. Should the range get bigger or smaller?
Bigger.
Yeah. Let's see. Actually, I'll put this in brackets. Yeah, much bigger. It's 1.7 kilometers now. Whereas what was it a moment ago? 250 or something, wasn't it?
Yeah.
Yeah, 250. Yeah. So the smaller the G, the more range you can get as well. Yeah. Okay, I just thought that was interesting tangent to be looking at. Let's continue then with the projectiles, because we have much more examples to do. Where's my physics folder? Okay, mechanics, projectiles. So previously, we left it in the middle here. I think I only did one example, wasn't it? With the boy kicking the football, yeah. So let's have a look at some more examples. Alright, so this, just continue where you left off in your notes. Let me just get us back to where we were. Okay, we have this. So we did this, didn't we?
Yeah.
Okay. Now what I was thinking of doing, I have two more examples to do, and I was thinking of doing this today as well. So what we can do is, I can do these two examples, and then we can do these together, taking turns for each one. Then if we get them all finished, then there's no homework from this one. But I don't know if we'll get them all finished, but we can try anyway. Okay, so here's the first one. If you want to write this down, I think it would be good. Got this? Wrote everything down?
Yeah.
You went fast, so. Yeah, go on, yeah.
I don't know the words. I didn't write everything specifically, but I just.
Okay.
I got the important info.
Your English seems good enough, I suppose. What's your IELTS?
That's it.
Suppose it's okay. What's advanced level? Is that 7 onwards, or is it 8?
C is advanced, correct?
Yeah, C1 starts advanced, yeah. But the IELTS give you a C? Oh, okay. I didn't know they did that. I thought they only give a number. Okay. Got this? And this projectiles question is pretty common on the exam.
For exam, we will also be having the numericals too.
Having what?
We will be having the numericals of the problem.
Do you mean like this?
Yeah.
Oh yeah. This would be a typical exam question.
Apart from essay, there will be some of them.
For the exam?
Yeah.
Oh, there's no essay in the exam. It's just mostly problem solving like this in the exam. Do you know what I mean?
Mostly.
Well, there's the odd definition.
Oh.
So I would say 90% like this, 10% definition or something that requires a description. But it's 90% problem solving, which I think is good. I think so, anyways. Okay, let's have a look at this one. Okay. Where is my pen? I can't see it. There it is. Come on, come back to life. Are we back? No, we're not back. Come on, you can do it. Right, we've got burger. Oh yes, don't worry, don't worry. So we have our grass here, we have our building here, we have our window here, and we have our person here. Okay, and then the ball is thrown. Right, so what do I tell you is the speed here? Do I give it to you?
Yes.
25, is it? And the angle is also... Oh, it's 60. Yeah, okay, so she's actually... This is 1 meter high. Yeah. The angle... I'm sorry, what did you say? 25, was it? And the... No, sorry, the speed. And the angle is 60. So this will be 25 cos 60. And this is 25 sine 60. And then this height here, I said is 25. I think that's all the information, isn't it? Can you pass me my calculator back, please? Right, so let's put in our information. Whoa! Don't worry, there's still coffee left. I got a tissue. It's my own fault, making a mess. Right. There you go. Let's put in our information. So we'll look at the horizontal first. U, V, A, T, S. The U, 25 cos 60. The V, do not know. A, 0. T, don't know. S, don't know. U, V, A, T, S. The U, 25.
But why is the V 0?
No, the V is not 0. I said I don't know the V. Yeah, the A is 0. Yeah.
So why isn't it 0?
It's still moving when it hits the wall. It's not at rest, you know. The V, don't know. The A, minus 9.81. T, don't know. Now, before you say it, just think for a moment. What's the S?
25. 25.
It's not 0. It's not 0 because it doesn't hit the ground.
Yep, and it's not 25.
Minus 25?
Good try, but no, not minus 25.
25 minus 1.
Go on, which is, yes, it's 24. Because you must always compare this to where it started. So it's displaced 24 meters vertically because it started here. Yeah, so it's 24. Okay, so what am I looking for? The time. Oh, I'm sorry. I'm so sorry. I misread the question. That's not 25. That is not 25.
Oh, the house is 25 meters.
Yeah, what does the question say? The house is 25 meters away. So where's my 25? Here. Here to here is 25. The range is 25. Okay. Actually, that makes the question a lot easier to do. Not that the other way was impossible. Which should I start with first, the X or the Y? x, because there's 3 pieces of information there. And because there's no acceleration, I can use my distance, speed, time triangle. Distance, speed, time. So distance equals speed multiplied by time. So then time equals two. Yeah? T is 25 over 25 cos 60. Okay, well that'll do it. Now, that you know the T, that means here, this is 2. Okay, so we want to now know how high it is at the end. So that means I want to calculate the S here. So S equals U T plus a half A T squared. Actually, this question turns out to be a lot easier than I thought.
This time 2 is for the y.
23.68.
The time is for the y.
The 2?
Yeah.
Yep. Oh, but this time you can use it here. Because the time it takes for it to go here to here is the same time to travel horizontally. So 23.68. So what is the height of the building? Or how high up does it hit on the building?
First, I'm seeing for the time of light.
Oh yeah, well we've got that already. There it is there.
So it's at what height it hits the
Yep.
building.
So what's my answer here?
It's 23.
23 plus 1, because that's for the height of the building.
Correct. Yes. Yes. I thought that wouldn't catch you out since we talked about it already. So we have to take account of this plus 1. Yeah. Okay. That actually wasn't so bad. That was a lot easier than I thought it was going to be. So we have one more example to do. Okay. Any questions about this? It's okay? Alright. Yeah, explain it again. Go on. Why 24? Yeah, go on. Show it off.
Because it has 1 meter.
Yeah.
Actually, yeah, the S is actually to here. Yeah. Okay. Right. This one's actually quite a common physics questions in the book. Thelma and Louise drive their car off the side of a cliff at the end of their movie. If you don't know the movie, it doesn't matter. The cliff was 400 meters high and the car was traveling at 36 meters per second. What was the time of flight? What was the range? What was the velocity of the car at impact? What was the speed of the car at impact? So you don't have to write down the full story. If you can just, even if you can just draw the information, that would be enough. Yeah, you can draw it if you want. Yeah? Do you know this movie? Do you? It's a very old movie. I'd be shocked actually if you knew it.
No, I can't watch it because I know it's gonna happen.
It's true, yeah.
What movie is it?
Thelma and Louise.
That's the name.
I think that's the name of the movie as well, yeah.
That was good. Model.
Okay. Did you draw it?
Yeah.
Yeah. Or have the information? Yes. Andy, you're writing it down, is it? Yeah? That's okay. Okay. Yep. So, let's have a look at this. Right, so this one's a bit interesting because obviously it's, well, let me just draw it first. What's the height of the cliff? 400 meters? Okay. And the car is going how fast? 36 meters per second. So what's going to happen is the car is obviously going to fall down quite badly. So let's have a look at the x and at the y. So at the x, u, v, a, t, s. The u, 36. The v, we do not know. The a is 0. T and s, we don't know.
Why is the a is 0?
This is the x. Yeah, not the y. Now the y. U, v, a, t, s. The u. What is it going? Yeah.
36.
No, because that was for the x. No. What's the u here? What's the vertical speed?
0.
Yeah, there isn't any. Car travels on the road. So the u is 0. The v we don't know. The a minus 9.81. The t we don't know. The s we do know. What is it?
Minus 400.
Minus 400. So should we start with the x or the y? Let's have a look at the y. What do I want first? The time of flight. Okay. Scrolling down. So we'll go with s equals ut plus a half a t squared. So t squared equals 400 over 9. What the heck? Sorry. A half a, that's the wrong number, minus 4.905 t squared. So t squared equals 400 over 4.905. So then t is the square root of this number, which we can get. 400 divided by 4.905, and that comes in at 9.03 seconds. So that answers the first part of the question, what is the time? The next part is probably the range. Yeah. So the range, that means we need to look at the horizontal. We now know that the time is 9.03. Using distance, speed, and time. Distance is speed multiplied by time. Yeah, so what did we get? 325.1 meters. So that's the answer for part B. Let me put these in boxes. Yeah. Part B? This part? Well, I use distance, speed, time triangle. I now know the time from part A. We worked out the time is 9.03. So I can use my distance, speed, time triangle. Distance is speed multiplied by time. Okay, what's the next part? The velocity at impact. Okay. So if I zoom out a little bit, that means velocity, scalar or vector? Vector. So we want to know the vector at impact. Okay, so we can work out the Vx and the Vy. Now the good news is actually, because there's no acceleration, we actually know the Vx already. What is it? If the acceleration is 0, if it starts at 36, then finishes at 36. From v equals u plus at, the a is 0. So we know that this is 36. What we don't know is the vy. So let's calculate that. That will be what formula? U plus a t. So if I just do 9.81 times 9.88, 88.58. So that's 88.58 meters. So that's the velocity. It's, I'll write it here, 36 meters per second right, and then 88.6 meters per second down. That's the velocity. So they're going a lot faster down than they are to the right. And the last part is the speed. Now, how do I get the speed?
Will be the same.
No, because speed's a scalar. So there's no direction.
Sorry, 88.6 meters per second down, that means the negative. I don't have to write the negative, correct?
Yeah, because I wrote the word down.
Down.
Yeah. How do I get the speed? The speed is this part here. It's the magnitude. Remember, speed is the magnitude of velocity. So, by using Pythagoras, I can get the speed. The speed will be square root these two numbers squared. So, square root 36 squared plus 88.6 squared, that equals 95.6 meters per second. Okay, so remember, speed is the magnitude of velocity. Yeah? We're happy? Happy enough, I suppose.
Why do we use 36.88?
That's the velocity, okay? So like here, I'll go back, don't worry. This is the speed here, and then this is the resolved velocity. So we're going backwards from the resolved velocity to the speed using Pythagoras. Yeah? So the final answer, that's the speed, and the previous answer, that's the velocity. So hang on, this is A, B, C, and D. Is that okay? Continue? Not yet, Mir? No? Okay. Continue? Are we just waiting for Mir? No, we're waiting for you too? Okay. Now we're just waiting for one person. So it'd be nice if I can finish Projectiles today, so we can work on the questions together. Maybe we'll take turns. You do one, I do one, you do two, then I do two. Yeah? How many questions do we have? Let me think.
6.
6. Yeah, it's just 50 minutes divided by 6. Yeah. I don't think it should take maybe 4 minutes to do each question. They're not that long to do. They take long to do to explain, but once you're doing it, it's not much to do. So how about we'll take turns. We'll spend maybe about 5 minutes per question. Then I'll do the answer, okay? If you get it finished, then just start the next one. The first one should be quicker than the last one, of course. So maybe for the first one, less than 5 minutes. So try the first one here. Let me just stop the recording and start it again.